Hello, welcome to another Open Geospatial tutorial. In this video, I'm going to show you how to do building detection using Segment-Geospatial, specifically built on top of Segment Anything model version 2. So first, I want to show you what it looks like. And this is kind of demo. So it will allows you it allow you to basically do interactive segmentation. So you can click, for example, place a couple markers on the map, and you will basically detect the buildings automatically. And you also can regularize buildings, basically give it a building footprint or the building outlines, and you can save that as vector data or raster data. Alternatively, you can also export, for example, this is just the building outlines in here. And you can also build on top of other deep learning models. So if you already have some points from other deep learning model, for example, you already know the rough estimation or the rough locations of the buildings, you can use that directly as the GeoJSON file, and then you can input into the model. So just with couple lines of code, you can detect buildings very easily. So this is what I'm going to show you in this video. So if you want to follow through, you can go to the Segment Geospatial website, samgeo.gshub.org, and then on the left side here, examples. Scroll down to find SAM2 point prompts. So this is a new one that I just added yesterday, and you need to update to the latest version if you have installed that one before. So I would recommend you just use Google Colab. So just right click, open this one in Google Colab, and then you can uncommon this one here, just remove the hashtag. Before you do that, you need to switch to the runtime to GPU, otherwise it's going to be pretty slow. So change the GPU runtime and then change to T4 GPU, then just click save, then you'll be using the GPU, so it'll be so much faster. And after that, it's going to be the steps step by step, so it's pretty very straightforward. And I'm going to run it on my local computer here, and so it's little bit more smooth. And then I'm going to show you step by step easily how to do that using Jupyter Lab. So here, first you need to install the packages. Like I said, you can either use pip to install on Google Colab, or you can use Mamba to install it on a local computer. After that, let me restart the kernel. So in about all the outputs. And so first you need to import SamGeo2. So this is the new version that I implemented a couple weeks ago, but I just added basically the point prompt. So allows you to enter points or you do selective segmentation easily. And the regularize function is used to, after you get the raster mask, you can convert it to vector data. So first, let's create an interactive map. So I'm going to center the map around here in Washington State in the US. So we're going to have some of the buildings in here, and we're going to use this as an example. So you're welcome to draw a rectangle here, or you can just use my sample data set. So avoid using a large area because you might not have enough GPU. So you can just run this one, and then it's going to download the map tiles and going to mosaic, excuse me, mosaic them as a geotiff. So on the left side here, you see satellite.tiff, and it's a tiny file, so only 4 megabyte. You're welcome to use your own dataset. So if you have some other files you want to utilize, you can also just uncomment this one and then just change the file path to your own dataset. It should work well. And after that, we can just add the raster to the map. So I'm going to execute this one and it should show up. So we're going to basically turn off the base map data layer. So basically the Google satellite, we set the visibility to false so it doesn't show up. And right now, this is the imagery that we're going to work with. So I'm going to show you how to actually can detect the buildings from this satellite imagery. And upper right here, this is just the layer control. So you can turn the layer on and off, and you can change the opacity interactively if you want to. And there are a couple ways you can do the segmentation. So I'm going to show you. First, we need to basically initialize the same geo. So we're going to use the same geo tool. We already imported, and we're going to use the same geo, the large model. There are a couple different models available, so you can take a look at the model ID. By default, it's going to use the last one, but you can also use, if you have a small GPU, you can use small, base plus, and also the large or even the tiny one. And if you have GPU, we're going to, by default, it's going to use the GPU. And you need to turn this automatic mode to false. Otherwise, you're going to segment everything because we're going to use the point prompt. So we don't want to do automatic segmentation for the entire image. So this is right now is loading the model to the GPU, and the next step is to set the image. So the set image basically we are telling the model, okay, we want to segment this image. So and just run this one line of code, and that's it. And after that, we can do the segmentation. So we're going to use the function called predict by point. What this one is doing is that you can provide a couple point prompts, and this it can allows you to segment, for example, provide a couple points. So what we are doing in here is that you can either select points interactively, or you can use these 4 points that I'm showing here. And I'm going to show you, for example, they say, okay, zoom in here, and you can use this marker, the drawing tool here, to draw the marker to basically use whatever point you want. So for example, I want to place this marker. They say I want to detect this building, and so place a marker. If you want more, I can place a couple more example in here, and that's it. So they say this, I want these 4 buildings. So what this one is doing is actually, you can use the one that you created, or you can use my default one. So these 4 points in here. So if you want, you can actually take a look at the point that we just placed. So map.user RI s. This one is going to show you the geometry. Basically, the 4 points that we just placed on the map here, and this will be the coordinate, the latitude, the longitude, and also the latitude. So x and y, x and y. So we're gonna put this one inside the list. So this is a list of coordinates. So what you need to provide is a list of longitude and latitude. That's it. And after that, what we need to do is just call this function same dot, because we already initialized the same model. So we're going to use the same predict by points. And what you need to provide is this a list of points. And since right now we're using the geospatial data, so we're using longitude, latitude. So you need to change this one, the point CRS to EPSC 4326. So basically the WGS 84. Otherwise, you need to provide the absolute uh, X and Y, basically the column number and also the row number. So those usually in geospatial, we want to use some coordinates. And so make sure you change this one. Otherwise, you want to get incorrect results. After that, you can specify whether you want to save the mask. You want to save the mask as mask.t, and you can also specify the output data type. And pretty simple. So what we're doing here, we already use this one. So again, you need to run this line and then just do the segmentation. That's it. And you see here, it's pretty quick. So only like a couple seconds. After that, if you refresh, you should have this mask.t. So this is the one that has already been segmented, and the next code block here is adding leg one to the map. So let me remove this one. So run this code block, and we still have the point, the markers in here, but now you see the new data layer. So it's going to showing up because I'm using a remote Jupyter instance. So it's going to take some time to load up. But clearly you can see right now we have these 4 buildings has been detected. This is the mask, and by default the opacity is 0.7. So basically 70%. You can change the opacity. Really good, right? Of course, there are some like shadows, so sometimes this is kind of a tricky for deep learning models, but for other ones, you can see it's pretty close. So this is what you can do. Basically, just provide a list of points, and then you will detect those builds for you nicely. And there's no training, there's no building the model. All we need is just the foundation model, and that's it. So um, if this is something that you want to try, you can try it out. But sometimes if you have a lot of buildings that you want to detect, it's certainly not very convenient that you need to click so many times. So you can just provide an existing vector data. So this one here, I provide you a sample data set, basically the building centroid on GitHub. And this, like this, for example, plot that on the map to see what it looks like. So I'm going to just pointing the GeoJSON, and then we can just add the raster. So I'm going to add the image that we downloaded, and then I'm going to add all the points as circle markers and show that on the map. So this one, just take a look what it looks like. So all the yellow points here, as the red outlines, these are all the centroids, the buildings, for example, from other deep learning models, or you can create manually. So it's up to you what you want to do. So for example, this is not perfect. You want to see some of these. This already updated. Anyway, so there are still some that missing in here. This is basically the data is not perfect. There are some of the buildings that don't have a centroid. That's fine. And but more the majority of buildings you will see they it has a big point in here. So what we need is basically just a GeoJSON that with all the centroids, all the buildings, and then we can do the same thing. So when we set the output, we call the same function. The only difference right now compared to the previous one, a list of coordinates, is right now we are providing HTTP URL to the GeoJSON file, or the file can be local GeoJSON, or it can be HTTP URL. And then we're going to specify the output, data type, and also multi-mask. We can just set multi-mask to false because by default it can output 3 masks, and they have different probability. You set multi-mask to false, then you just pick up the highest probability. So basically the base likelihood, the highest likelihood. So just do the segmentation and they see what it looks like. This one is going to take a little bit longer because we have, I think, over 200 points, and it's going to take yeah, only a couple seconds, and that's it. So now this is the output mask on the left side here. Now you see this one building underscore mask.tif. Then we can actually add this one to that. So zoom in and take a look. Very nice. So this is just a random color. So the color basically just represent different, basically unique buildings. And if you zoom in to see, it actually pretty nice because these some of the buildings are not detected because it's we don't have a point in here. So you can certainly improve the building centroid to get a better result. But at least from initial inspection, it's pretty good. So the building mass, yeah, uh, not bad. And it's only a couple seconds. Again, you don't need to build a model. All we need is just use the automatic segment anything model, and then we utilize SameGeo because SameGeo can help you handle all the geospatial data, so you don't have to do all the conversion by yourself. And once you have this building, you can actually do some cleanup because if you look at some of the results may not be perfect. I think there's some, for example, something like this. So this one here, this is a single building, but it's not actually not um, you have 2 points, right? So the building has some artifacts in there. And sometimes you might need to clean up. You want to treat this one as a single building. You want to fill some holes, for example, and just merge different polygons. And so here in the same geo, I created this function that allows you to clean up the results. And so this is, for example, this we're going to build on top of this one, the building mask. This is the one that we created. So this is the one I'm showing here. And we can call this region groups. The region group function is basically just going to detect objects, and you can set a minimum size. For example, they have some like small objects that are very tiny. You can actually remove it. So and after that, you can output a new image. For example, the building, the unique ID, and then you can also create a vector polygon. So what we're doing is just calling this region group function, and then input will be this one, minimum size 200 pixels, and output the vector data and also output the image. And you can also return a numpy array and also a geodata frame. So basically, the vector will be the geodata frame representing this vector data. So this can be useful sometimes if you want to do some data processing top of the geodata frame because you want to count how many buildings, you want to calculate the total size or something like that. So you can just run this geodata frame head. This is going to show you the labels, so different buildings. You can show the total, for example, how many buildings in total, GTF altogether. So 239 rows, so basically 239 buildings, and they have all the attributes. For example, the area. So keeping in mind, the area is the number of pixels. This is the first building, for example, the number of pixels um, is 1842. So you need to look at the basically the metadata of your imagery. For example, this one is 0.6 meter resolution. So each pixel is going to be, for example, 0.36 square meters, and you're going to multiply it by the number of pixels, then you get the total area. So you do need to do some conversion, but you have all this information in here, the convex area and the major axis, minor axis, and also eccentricity, orientation, perimeter. The last one is the elongation. So the elongation means if you are detecting buildings, if something is very elongated, that might not be a building. That might be some roads or other stuff. It might be artifacts. So this gives you some information that you can filter the data set to something that you want. And you can also, for example, GTF.explore. This should give you, not sure if I have the package installed. Okay, yeah, works fine. So now take a look. It's cleaned up. So looks pretty close. You still have some of these things in here. You might need to basically, for example, this one, the elongation is 0.97. Looks pretty close, but you can use some of those attributes to do some filtering to clean up. And at least right now for this here, you don't see loads of holes, right? We already fill the holes using the region groups. And this is relatively clean polygons. Might have still have some minor artifacts, but this is like not much effort. Take us a couple seconds, we get the result. Do some cleanup. And the next step, if you want, you can also regularize. So that means some of this building here, although it's kind of a looks like buildings, but it's not perfect. So sometimes you might want to basically create a rectangular polygon. This function here allows you to create a rectangularized polygon. And this is the final step that shows you everything. Take a look at this here. We have different color, basically means the buildings. And we also have this building outline representing the outline of the buildings. Regularize and so all we need is just basically the imagery and also the points, the center of those buildings. Then you can do the detection. So it's going to so much faster than you are trying to delineate manually by yourself. That's going to take a lot of time, but we only take maybe 10 seconds. Then we can automate the whole process to detect all these buildings. And this is how you can do like base processing. You have all the centroids of the building. The last one I'm going to show you here is even more interesting. So this can actually allow you to explore how the algorithm performing. So for example here, after you just call this same.show map, you will need to set the image first. And after you set the image, if you call this show map, it's going to have this interactive GUI here, allows you to um, extract buildings automatically. It's similar to earlier when we placed marker, but you can place multiple markers at the same time. So what I'm going to show you here is we're going to classify, for example, foreground basically is the type of object we want to detect. So I'm going to click this one here, one, and for example, this will be the four buildings we want to detect. Then just click this segment, you see, 1 to 2 seconds. Then you have this one, and you can also change the opacity of the mask. And this is all interactive. So it changes to 70%. And you can continue to add more points. For example, I want after that, I want some more like this. And this is super quick, right? Rather you have to create the outline manually by yourself. Right now, I'm just doing interactive segmentation. And it's going to detect all the buildings nicely. Just like what we did for the GeoJSON, but this is more like interactive where sometimes you're only missing couple buildings and you want to detect them, then you can continue to add more points just like that. See, you have all the buildings and you can also regularize just like what we did programmatically. So you click this one and then you can regularize. You're going to have all the rectangular buildings here. Super easy. After that, if you want, you can click the save button. Then you can save all the raster and also the vector data. You also save the markers to the map so that you can load it later. For example, I'm going to click this one. And so here, I'm going to just click the mask, maybe about mask 2. And click save. Select the left side here. You should see the mask, this one, and also the vector data. So you're going to convert this to vector data. And this is the rectangular object. So basically the building outlines in here. Also we have this marks two FG markers, GeoJSON. So this is the foreground markers. So if you use this one as platform to collect training data, sample points, you might want to save this one. So and later you can reload it. For example, you have clicked these points, you don't want to start over again. So I can just reset. Let's say right now, this is the new image that you just loaded, but you have some points from your previous task. I can just click this one here, click this low foreground points and select, and I'm going to select this mask 2 foreground markers, select, then you should load all the points. Once you load all the points, you can just do the segmentation, then you should have this segmentation back. And again, you can continue to add more points. For example, right, I continue my task. Now I click this mask, I add a couple more points. Okay, and then I segment again. All right, and I can also do regularize. Right, so this is basically built on top of what we did, and same thing. I can right now save the task. I can save this one as mask 3. Active, select OK, and you should have the mask 3 here again, right? So now I have the new marker. So you can continue to build on top of this one. It's very powerful. It's very easy to use, and it doesn't have to be buildings. You can actually detect any other features as long as you have the points. You select multiple points. For example, it can be, for example, for this one, I can detect just the rows and other stuff. So let me just reset this one, give it a try. For example, maybe I want to detect um maybe trees. I'm not quite sure if it works or not, but how about this? We have a couple trees in here, and I can place a marker here. X. Nice. Right? So you can detect the trees. Although, I mean, this is not as obvious because it is not as obvious buildings. But if you want any features, you can place markers there to be able to detect all of those. And so the more points you have, the more likely it's going to pick up large objects. And so this might not be what you want. Then you might need to do some fine tuning. Again, if this is not right, you can reset. And maybe, okay, I want to detect this whole one. For example, this tree in here. I can click that. Detect all of them. Okay, even some of these in here. It's nice. It works best for buildings because it's have the basically the clear cut boundaries between the background and also the foreground. These things might not be perfect, and sometimes the foundation model, so you might get some unexpected artifacts. It's perfectly normal. This is why sometimes you might need to do. Anyway, so this is what I want to show you. You can try it out. Again, try out in Google Colab. You can do it for anywhere, any location that you like on the globe. Just download some sample data, or you can provide your own data, and then you can detect building to for your project. Okay, so that's all for this video. I hope you find it useful. I will see you in the next one. Take care. Bye bye.